This is a model of an electric motor. Everything that's yellow is conductive. Okay, here's our voltage source. Okay, this is the positive terminal and this is the negative terminal. And we're going to be using conventional current in this demonstration. This represents the magnetic field, which right now is directed perpendicular to the face here of the loop of conductor. The A represents the surface area. Now, right here, this is called a split ring commutator, and the black portion here is non-conductive, and that's on the other side as well. And when I place this in this position with the non-conductive part in contact with this, which is a conductor, and also on the other side, same thing, there is no current drawn from the battery. Now, if I give this a little push like that, now all of a sudden there is contact, electrical contact between the split ring commutator and this conductor here. Okay, let me just move this away so you can see that. Okay, so at that moment there will be a current drawn from the battery. Now remember, we're using conventional current, so that's the flow of positive charge. That current will follow this path. It will go like this, and then it's going to come up here, make a left, and go up. Okay, and I'm going to represent that current with this orange arrow here, and I'll tell you what the red arrow means in a moment. Now, using the right-hand rule, if you point your thumb in the direction of the conventional current, and then these fingers in the direction of the magnetic field, the palm of your hand points in the direction of the magnetic force. So there's a magnetic force acting this way, okay, like that, and that's perpendicular to the magnetic field and the electric current. And that also is true on the other side. Okay, so over here the current is going down. If I use the right-hand rule, point my thumb in the direction of the current, these fingers in the direction of the field, you get a magnetic force, point it this way. Again, perpendicular to the magnetic field in the current direction. These two make up a force couple, and they exert a torque about this axis here, causing it to rotate. And when this loop is in this position, we get maximum force, okay, maximum torque. The loop continues to rotate, and now that non-conductive portion of the split ring commutator comes in contact with these two conductors, and the current is shut off. Magnetic force goes away, but this continues to coast, and the process is repeated. Current goes up here, magnetic force directed perpendicular to the magnetic field in the direction of current. Over here the current goes down, and the magnetic force, using the right-hand rule, magnetic force is directed this way, perpendicular to the magnetic field in the current direction, conventional current direction. The torque keeps it rotating. When it's in this position, current is shut off again. Magnetic force goes away. Newton's first law coasts. Current turned on again. Okay, so what we have here is an electric motor. And up here, I have a model of a fan. So as the motor turns, okay, if you notice the way this blade is angled, it's pushing the air down. We're going to get a breeze below the fan. Let's take a look at this now in motion. I made a stop motion to show it in operation.